But in terms of what happens in microgravity, in terms of what happens to biology in microgravity and how biology behaves in microgravity, it serves a great purpose to the healthcare market because, one, it creates in space a number of opportunities to use space as a research model, as an analog, so to speak, for disease on Earth. And that's incredibly valuable to industry when they're trying to challenge that disease with a treatment that ultimately might be beneficial to humans on Earth. But also, same way that biology behaves for research also means that you can leverage it to potentially make treatments in space as well. So I think there's a big value there.
Yeah, and in addition to that, I think that the initial markets, as you said, kind of on the biological and health side, but even before that, obviously the replacement of the space station that you also mentioned, but on the military side as well, I have the luxury and honor of serving in the military for over 2 decades, and the new mission areas that the U.S. Space Force is exploring in space assembly and manufacturing, active debris remediation, all of these kind of things are going to bring new capability and new markets that we're really getting excited about, and that the government is actually taking steps to start to provide funding, and folks are really building new capability that can provide servicing for satellites, interchangeable sensor systems, active quick response, satellite servicing and refueling, all of those kind of things I think are exciting. There's companies that are taking recycled materials and turning them into spacecraft fuel and those kind of things. And with our infrastructure that we'll have in space, the ability to make that stuff happen at scale, I think, is really what's next.
Fascinating. Everybody here on the panel is developing that infrastructure right now. So I think it's quickly becoming a reality. I think the other element of this, this kind of the invisible hurdle, right, beyond the physical challenges that we have of putting anything into space, is the regulatory environment. So it's making sure that we have the appropriate controls in place. And Christian, I think you touched on that earlier, but making sure that we have the support of the regulators, that as we start to manufacture and produce these items in space, that then they can be used appropriately and legally within different consumer markets here on Earth.
Right. I think it has to be with the speed of physics to understand what the limitations are, right? Because if we start limiting the way we do business by the regulations, by the different factors that are out there, then you won't be able to explore the possibilities. So if we can understand what needs to be done physically, make that happen very, very quickly on a commercial type of scale. I mean, we learned this lesson over and over again when I was at SpaceX, where if you drive fast, if you let physics be the only limiter, and then worry about the other stuff later. Those are all rules that are made up by humans, sometimes for a good reason, sometimes not for a good reason, because it's the way it's always been done. And if we carry that mentality forward in the manufacturing world, we're dead. So we've got to figure out a way to go fast.
Totally agree with you, Lee.